Okay, I think we're in section 110 now. Let me get to 110. Again, this is a table of contents. Just to remind you that to get to a section, I know it's a very long document. Even the table of contents is long. But to get to 110, what you do is find the table of contents and just click on it. All right, so 110, I'm going to click on it, and it'll bring me right to 110. All right, so we're at actually page 1841, at least in the present document, you're at page 1841. Again, I want to point out we'll cover 110. Typical of these sections over there will be content to read through and make some attempt to understand. Examples that we'll work on, I'll explain the examples in the way I'd like to explain them, and then exercises for you to work on. We're hoping the content and the examples that we give you is sufficient for you to work through the exercises, although the exercises can be very difficult. All right, my name is Ron Bannon. This is a draft version of my adaptation of Webster Wells's Advanced Course in Algebra, date back to 1904. This document, the PDF of it anyway, is being prepared for the Prison Mathemagic Project participants only. I realize there may be people watching these videos that are interested in obtaining a copy of this. It's not published yet, but when it's published, I'll let you know. Just reach out to me. My email address is Bannon, that's B as in boy, the @ symbol, NNON.US. All right? So it's a tough read, this section. So they talk about the differential method. And this is going to be used in other sections as well, right? They talk about it and they explain it to you and they explain the relationship, again, differential method, and they explain how to do it, all right? And they go through this method that they'd like you to follow, and we're going to go through that for you, all right? So basically what I'm doing, I'm talking through what they're talking about. One thing I talk about is that this seems like an odd thing, but pile of shot, they're like cannonballs, and I'll go through that for you, all right? So I guess back in 1904, prior to World War I, that is, I guess they had cannonballs that were stacked up. You can still see this in historic displays, by the way, where next to a cannon would be a pile of shot, right? Usually neatly piled, by the way. So the reason for that, you want to be neat when you're piling shot, I guess. But anyway, let's go to the examples. And as I do this over here, I want to point out that I don't see this as a difficult problem, but that's not the point of it. The point of it is that they want you to do their method. So before I do their method, I want to point out, I'm looking at the sequence, and I got to be honest with you, I'm looking at that sequence, and it looks clear as day what that sequence is. There are many sequences it's not clear as day, but this looks like 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed. I think you get the, I'm sorry, I put the wrong thing down there. I think you get the idea. I'm seeing that. I'm seeing it clear as day. Again, the first term is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. And they want the 12th term. Well, I'll tell you, this is the first term. I'll call it A1. This is A2. This is A3. This is A4. Now, I'm not going to go to A12. I'm just going to say I know what A12 is, right? What's it going to be? 12 cubed. And that would be A12. All right? Now, I'm not saying you have to do the multiplication, but it's not bad to do that. I'll write this down for you. So 12 cubed. And again, this is me just simply ignoring whatever Wells said about how to do the problem. I understand this is pretty simple to do. I want to make sure I can do that. 12 cubed would be 12 squared, which is 144 times 12. Well, I got to do that arithmetic. That's 1,440 plus, and 2 times 144 is 288. So what do you get over there? Let's write this down. We'll check it with the key. 8, let's see, 12, 7, 1728. I'm seeing that right over here, right? And I'm going to erase that now. I'm just going through, if I were looking at that, I would not do what Wells is doing. But that's not the point. We're going to learn what Wells is talking about because it's useful. I'm just saying if I saw that sequence, I don't think I would do what he said. The next thing I want to do is he talks about the sum of the terms. So I want to point out that you may notice at the end of my appendices, I talk about how to derive these formulas. But right now, I'm going to write the formula down. So if you have 1 cubed plus 2 cubed plus 3 cubed plus yada, 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 up to n cubed, this is a very easy formula. It's also easy to derive, by the way. But let's not worry about that. Let's just say, I know this. It's n plus 1 over 2 squared. So I'm going to write that down for you now. So what do they want? They want 1 cubed plus 2 cubed plus 3 cubed plus yada, yada, yada up to 12 cubed. What's that going to equal? Well, let's put the formula down. It's going to be 12. That's what the n is. And then n plus 1 would be 13. What goes on the bottom? A 2. And they're going to square it. Again, I'm just going through what I would do if I were asked this problem. I wouldn't do what Wells is doing, but I'm still going to go through that technique. All right, now looking at that, what do I get? I got to do the arithmetic, right? So it'd be 12 squared, which is 12 times 12. 13 times 13. Yeah, it's a lot of work. The bottom is 2 times 2. Well, 2 goes into 12 6 times, and 2 goes into 12 6 times. So I get 6 times 6, which is 36. I'll write this down for you. And 13 times 13 is 169. All right, what I got to do is I got to do the multiplication now, and I'll write it down for you. Again, understand in Wells's days that multiplication was done, a lot of times in people's heads, they were quite good at it. I think we've kind of lost our way with respect to that because we're so used to using calculators. But anyway, I'm going to go through the multiplication. 6 times 9 is 54. 6 times 6 is 36. 36 and 5 is 41. Let's see, 6 times 1 is 6. 6 plus 4 is 10. Let me get my eraser. I'm going to erase my carries. And now I'm going to put a placeholder. That's 36 as a 10. So 3 times 9 is 27. 3 times 6 is 18, 20. 3 times 1 is 3. 3 plus 2 is 5. 4, 8, 6, 0, 8, 4. I want to point out that's written over here somewhere, right over here. All right? So I'm going to say that's what I would have done. I don't think I would have went this differential method, but that's not the point. The point is that we want to be able to do the differential method because you're going to be given sequences that you don't understand. All right? So let me make sure I'm erasing everything. I got to start anew now. I got to do this differential method over here. So I'm going to say this is the list of terms, and I'm going to call that the set of A's. And I'm going to just write over here what A1 is. A1 is 1. That's going to be important if I use the differential method, by the way. And now what I want to do is I want to write down the successive differences of that set, and I'm going to call that the set of differences. But it's the first set of differences. And again, this does look a little different than Wells writes down. But what are the differences going to be? And I'm not going to extend the list, by the way. I'm just going to write down the difference I'm seeing, hoping I see some kind of general pattern that peters out at 0. 8 minus 1 is 7. 27 minus 8 is 19. And let's see, 64 minus 27, that is 37. And I'm not going to go beyond the list of terms that I realized in my blue area I did. But let's see what I got over there. Next up, I got what? I did 64 minus 27. Now I'm doing 125 minus 64, and that's going to be 61. By the way, this goes on forever. And I'm going to say the D1 now, this is the first difference I've got, is 7. And now I'm going to do the next set of differences. I'll write this over here, difference. This is a set of numbers. And I'm hoping for a nice, easy pattern. And I'm not saying I'm there yet, but let's take a look. Let's see. The difference, 19 minus 7 is 12. Let's see. 37 minus 19 is 18. And 61 minus 37, 24. And again, this goes on forever, but I kind of petered out. I didn't really extend my list. I'm just going to say now D2 is that first term, which is 12. All right? So let me just point it again. A1, D1. Let me outline this for you. Make sure you know these are important. I got this now. Now, what's interesting about that? I'll write down the difference. Got to put it on the side because I'm running out of room, right? Get my eraser out again. The set, the differences, the third set of differences. Well, looking at 18 minus 12 is 6. And then 24 minus 18 is 6. Wow, remarkable. So I'm going to say D, and again, I didn't extend the list. I realize you might say there's a good deal of trust involved here. So let's say D3 now, right? That's going to be 6. Now let's put down differences 4. Now again, I understand if you're doubting Thomas, you want to look at my work, but this would be 0. I guess you'd probably know that D4 is 0 now. And everything that follows is going to be 0. The differences between zeros would be zeros. So D4, D5, D6, D7, D a billion 0. All right? So someone says, that's already written down for me, and it is. So I'm gonna erase it, but this is my explanation. All right? So the only thing I don't think I've written down there, I'm going to write it over here. I'm going to start to erase. I don't think I wrote down A1 for you here. So A1 is 1. And I'm gonna again emphasize what we need here. We need this. We need this. We need this. We need this. And I need to know that D4 forward is all going to be 0. All right? So then I got to do this differential method now. So, and again, this was derived in the set. I'm going to start to erase this business over here. I'm done explaining to what was written down. I realize the list that I've written down in the blue area is much more extensive, and you may want to consider that, just to convince yourself how nice and easy this thing is to do. But now I got to write down this AN. So I'm going to write down the formula for AN, and then we'll plug the numbers in later. AN will equal A1 plus N minus 1 D1 plus, it's got a very nice pattern to it. It's almost easy to remember. So N minus 1, N minus 2, this was derived in the contents, 2 factorial, and that's D2. And then I could keep writing this thing. And this goes on forever. But the pattern's easy. What are you going to get? N minus 1, N minus 2, N minus 3 over 3 factorial. Then you get D3. And, yada, yada, yada. It could go on forever, by the way. All right? But what's nice about this, when I'm kind of looking at it, I know what they want. They want A12, right? So I'm going to get my eraser out. And wherever I see N, I'm going to put 12 down now. Wherever I see N, I'm going to put 12 down. Let me just erase them, okay? Now, some people say, why aren't you putting down like D4 forward? They're all 0, right? Everything after this is a big 0. Everything. So 12, 12, 12, 12, 12, 12. All right, what's A1? Well, A1, if you recall, was 1. Then I'll put down the D1, I'll put down the D2, and I'll put down the D3. So 1, 7, 12, 6, and then a bunch of zeros there. I'm going to erase that, all the zeros there, because I don't need them. They're all 0. I got some arithmetic to do. And I'll write this down, A12. Now, you may recall we've already computed A12. We know it's 1728. I'm not saying I don't make mistakes, but I got to be careful now. So I get 1. That's the first term. Then I get 11 times 7, which is 77. Plus, well, it's going to be more difficult for me. And what am I seeing over here? I'll write it down inside. I see 11. And then I see 10. 2 factorial is 2, and I see 12. Well, I'm going to do 2 into 12, which is 6. And 11 times 60. Well, that's going to be 660 now. And yeah, it's a lot of work. Let me get my eraser out. Get rid of my chicken scratch over here. I'm going to do the next guy now. And what's next guy going to be? 11, 10, 9. 3 factorial is going to be 3 times 2 times 1 is 6, and then a 6 over here. They cancel off. And what I get 11 times 90, which is 990. And again, everything else is going to be 0. All right? Let's write this down now. It's work. I know that. I'll get my eraser out. And what do you get there? Let's take a look. Equals, whoops, I got to put an equals on here, don't I? Boy, it's a lot of work, isn't it? 78. And 660 and 990, that's going to be, let's see, 1050, 1650. Hope I didn't make any mistakes here, right? And I got to add them together now. That's what we put 1650 and 78. That's 8. That's 12. 1728. Just like we said it should be. All right, remarkable. All right, so I'm going to say that's done. And now I got to do the sum using this differential method, by the way. So let me just erase this business here. Erasing everything I've done, all chicken scratch. I'm just, like it's me doing homework. Not this. Now, I hope you remember we did the SN. And the SN was over here. That was S12, right? Let me outline where that is. We did this already. You remember we did this. Let me make sure you know what I mean by that. We did this before with a formula, and they're just using the same form over here. But now what I want to do is I want to go to the differential method, all right? So I'm going to just go to the next page. I'm going to show you where this is written. And I'll write down the formula, all right? And the formula for SN, we'll put the numbers down later, is going to be N times A1. Again, if you can't remember what A1 is, we'll look on the next page to get that. I'm sorry, I don't mean to put S12 down. Let me just erase this. This is also very easy to write down. It's going to be N minus 1 over 2 factorial, D1, this was derived in the notes, plus N minus 1, N minus 2 over 3 factorial, D3. And I hope you remember that when we got to it. If you can't remember, we'll scroll back. I hope you remember that once I got to, D4, everything's going to be 0 after that. So I'm not going to write them down. There's a bunch of zeros over here. In fact, I'm going to erase them. All right, I'm going to erase it for you. Okay, so what I'm going to do now, in place of the N, I'm going to put a 12 down now. So wherever I see N, you know what? I did something crazy over here. I got to erase this thing, right? N doesn't belong there. I don't know how that happened. Okay, wherever I see N, I'm going to put 12. Let's put that down. I know that's tough, by the way. Now, do you remember what A1 is? Well, if you don't, you have to scroll back. And A1 was 1. Do you remember what D1 was? And scroll back. D1 was 7. What's D3? Let's scroll back. It's 6. Let's put that down now. Okay, let's do the arithmetic. It really doesn't look bad. I'll write this down over here. 12. That's the first term. The next term is going to be, I'll write on the side for you. It's 12 times 11 over 2 times 7. Well, 2 goes into 12 6 times, so you got 6 times 11 times 7. That's going to be 66 times 7. That's 420. I'll have to erase this in a second. And 42. And that's going to be 462. I'll write that down for you. Let me erase. By the way, I'll know I made a mistake if I don't get the right addition. And I do make mistakes. I want to fess up to it when I do make a mistake. So let's put the next one down. And let me get that out for you. What do I got there? That's 12, right? And then 11. Then 10. On bottom, I'm getting 6. And I got a 6 over here. And 6 divides in 6 one time, and I get 12 times, let's see, that's 110, right? So that's going to be what? 1, 2, 0, 0, 1200, and 120, which is going to be 1320. I get my eraser out. The problem with erasing things, if I erase something and I wonder where it went wrong, I have no evidence of my wrong arithmetic. But I think I can add this together. And I think I made a mistake somewhere. Someone says, why'd you make a mistake? I didn't carry it out. I see the mistake right now. I got to rewrite this. I apologize. I don't know how I've done that. Someone says, how'd you know the number is wrong? It's so small, it couldn't be the right number. I got to write that down again. I apologize. So Sn, all right, what's it going to be? Na1, I wasn't thinking, n minus 1 over 2 factorial d1 plus n minus 1. I forgot to put down another term, by the way. I thought I was at 3, but I wasn't. I was at d2, and that's a mistake I made. This is d2. That's a mistake I made before. Plus n minus 1, n minus 2, n minus 3 over 4 factorial, and that's going to be d3 now. By the way, I'm not going to erase these things now. I'm just going to write them down for you. So I'm going to write down S12. And I'm not saying my memory is great. I make mistakes all the time, but n is 12. What was A1? A1 was 1. All right, I got to do the next one. I'm going to write it down for you. It's going to be 12 times 11 over 2. And what was D1? That was 7. Let me just go back and check. Yep, 7. Whoops, I went too far there, didn't I? 7. Plus, let me point out what I did. I did this, and now I want to do this. All right, what do you get? 12, 11, 10, and 3 factorial is 6, right? And what's D2? Let's scroll back up. D2 is 12. There was my mistake before. I thought it was at 4, but I was only at 2. Plus, let's put the last one down. That's 12, 11, 10, 9. Yep, feel free to use a calculator if you have trouble with this. 4 factorial is actually 24. 4 times 3 is 12. 12 times 2 is 24. 24 times 1 is 24. What's D3? I have a memory. I know it's 6. But you know what? Knowing and really knowing is all the difference in the world. I see that. And everything else can be 0 after that. Maybe I should put that down. Everything else is 0. Let me do my arithmetic. It's more of the problems I have to do. So let's take a look. S12. 12. That's the first term. It's going to be tough, right? 6 times 77. 6 times 7, that's 420. And 42. That's going to be 462. Let me do the next guy. And I'm going to get my eraser out. And again, if you're frustrated by arithmetic, please use a calculator. All right? So I'm going to say 12, 11, 10, and 6 goes into 12 2 times. 12 times 11, that's 120 and 12, 132. And 10 times 2 is 20. And 2 times 132 is going to be 164. So it's 1640. And again, I'm not beyond making a mistake all the time. I just made a mistake before, but I recognized because the number was so small. I knew I made a mistake somewhere. Let's do the next one. I got to write it down for you. And the reason I got to write the arithmetic down, so 12, 11, 10, 9. They're getting more difficult. And then, I'm looking at the 6 and 24. That goes in 4 times, right? And 4 goes into 12 3 times. 3 times 11 is 33. And 10 times 9 is 90. All right, 9 times, let's write this down. 33 times 90. 9 times 3 is 27. 9 times 3 is 27, so 29. All right, 2970. No, I don't enjoy doing this. And the point is I'm just doing the arithmetic. I'm going to erase my arithmetic over here, erase it over here, and I got to do some additions now. So I'm going to do, pairwise additions. I'm going to do 12 and 462. That'll be 474. And then 1640 and 1290. Let me write that down. 1640 and 2970. I think I might have made another error. The number's still too small. Where did I make an error? I got to look at it now. There's no way this is right. 3, 4, 5, 1640, and that. Did I make a mistake somewhere? 3. Well, let me add it together. Let's see, 11, 16. Yeah, I made a mistake somewhere. I got to go back over it again. You notice my other method was so much easier, right? Let's see where I made the error. 12 times 1 is 12. 12 times 11 times 7, that's 66 times 7. I'm going to do each one separately. 7 times 6, 42. 42, 46. Yep, I did okay there. Let's do the next guy. 12, 11, 10, 12. And 3 factorial is 6. Let's do that computation again. This is 2. 2 times 10 is 20. And then 12 times 11. That's 120 and 12, 132. And that would be 264. Oh, there it is. Okay, I see it now. That's important. I looked back over, and I had to say there's a problem. There could still be another problem. So let's do this again. 12 and 462 is going to be 474, 2640. That's 4. 7 and 4 is 11. 7, 11. That would be 3. And now I got to add the 2970. And what do you get? I'll write this down now. 4, 8, 10, 6. Got it. Good news. All right, let's go to the next question. And the next question I'm going to do, I'm just going to explain it to you. You certainly can do differential method if you want. But a lot of people look at this, they read it, they have no idea what they're talking about. And shot are like cannonball. All right, so I'm going to say if shot is piled in the shape of a pyramid, and that's typical. If you ever see a war memorial from early history, you'll see piles of cannonballs. And they're generally, I don't know if everyone's going to be a triangular base, but it says a triangular base where the bottom would have 9 shots in it. I'll put this over here. There would be 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm just putting the base down. And then what you do over there, you got a row of 9, then be a row of 8. You can line that up. You can even try it with marbles if you want. And then, I'll put the next row down. But I don't really like writing them down. But I'm going to say there would be 9 marbles there, or shot. There would be 8 there. The next one would have 7. The next one would have 6. Yada, yada, yada. Until you only got to the last one, which would just be 1 marble there, or 1 piece of shot. So I know what the base looks like, right? The base has, I'll write this over here, the base has what in it? It has 1 plus 2 plus 3 plus yada, 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 up to 9. Okay, I'm going to erase the base now. I'm going to talk about building on the base. And this is something that you realize that shot, if you got a base of 9 and you got to build up from that, it's going to be pyramid in shape, by the way. And I'm going to get my eraser out and erase this over here. And this is me looking from the top down at the ground. I'm going to erase all this business over here, though. And now I'm going to talk about, if I saw this thing on the ground, there would be 9 here. Let me see, I got 1, 2, 3, 4, 5, 6, 7, 8, 9. And then as you move up, you start to realize it's really the same pattern. But now what do I have? I have the next row up is going to have 8. You get the idea? So the base, the row up from the base would have 1 plus 2 plus 3 plus up to 8. Now I think I got a pattern here. The next one, the next row up, I'm going to work to my way at the top, would have 1 plus 2 plus 3 up to 7. Next one would be 1 plus 2 plus 3, yada, 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 up to 6. It's reduced by 1 each time. Then 1 plus 2 plus 3 up to 5. Then you get 1 plus 2 plus 3 plus 4. Then you get 1 plus 2 plus 3, 1 plus 2, and then you get 1. Okay. I'm going to write this down now. Right? So someone said, what do you mean you're going to write it down? I got a lot of things to add together. But what's nice about this is just the sum of the integers. And the sum of the integers, I'll write this over here for you, from 1 plus 2 plus 3 up to n is just equal to n plus 1 over 2. Now, if you look at the appendices, we go through some formulas, and they're easy to show. They really are. But right now I'm going to accept it. I'm going to write the first row down. What do you get? 9, 10 over 2. That's this row here. What am I doing? I'm using this formula. Let's write the next row down. And by the way, these should be very easy to compute. And what do you get? Well, let's take a look at it. You just get 45, right? Let's do the next row. What's the next row going to be? 8 times 9 over 2. And what does this give you? 36. So the base has 45 cannonballs, and the next row up, it has 36 cannonballs. Let's do the next one. I know it's a lot of work, but I'll write them down. And the next one's going to be, let's see, 7, 8 over 2. What do you get there? 28, right? Again, really reasonable numbers here. And the next one's going to be 7. I'm sorry, not 7. I put my head on. It's going to be 6, 7 over 2, which is 21. Let's do the next one. It's going to be 5 times 6 over 2, which is 15 cannonballs. What's the next one? 4 times 5 over 2, which is going to be 10 cannonballs. I think you get a pretty clear pattern over here. What's the next one going to be? 3, 4 over 2. And what does that give you? 6. What's the next one going to be? 2, 3 over 2, which is 3. I think you could probably visualize these things too. Yeah, they're pyramids. Well, they are. What's the next one going to be? Well, I'll write it down for you. It should be 1, but let's write this down. 1, 2 over 2, which is 1. Now here comes the problem. I got to add together. All right? And why do they get? They want all the cannonballs, right? So I'm going to kind of work my way down from the top. And I'm just going to do 2 at a time because I think it's pretty easy to do that. That would be, what, 70 and 11, 81. Don't worry, you have an SQ to look at. I'm going to add these together. That's 49. Now, by the way, I want to do these two together now. And 49 and 81, that's going to be 130. All right? Now, let me do these. These are a little bit easier for me. I'm going to just pick them off. 1, 4, 10, 20, 35. So all these together here are 35. So how many shots do you get? 130 plus 35. I'll talk about the method he's using instead. It's 165 cannonballs. Let's see how we did. And I see they're right over here. All right, I want to tell you what he's doing, though. And someone says, I don't want to do what he's doing. I don't want to do what you're doing. I want to do something different. we don't mind. You could even go out and buy cannonballs and stack them up if you want and see what you get. So what I want to point out over here is looking at it. Let me read it to you. Think of a single shot of silver marble and work your way down. So they're doing something different. They're working their way down. All right? And that for some people is easier to work your way down from the top. So they're working their way down. So, you'd have, the top would have 1. Right below it would be 3. Now, again, you might have to start thinking about this, but you're going to get these numbers over here. Now, I want to point out, did we get those numbers? We did. We got the 45. We got the 36. We got the 28. We got the 21. We got the 15. We got the 10. I'm just pointing out what I'm getting. 6, 3, 1. We did that. Our work gave us that. We got that. Then what did they do? They're putting down, let me just write this down too, because I didn't write down. I'll write down. A1 is 1. And over here, these are the differences, and it's pretty easy to write that down. 3 minus 1 is 2. Then you get 3, 4, 5, 6. Well, that's really easy, isn't it? 7. You get the idea. 8, 9. Really easy. What's the D1? Again, I want to point out that D1 is 2. And then you do these differences. What do you get? You get 1. Pretty simple. 1, 1, 1, 1, 1. So what's D2? D2 is 2. Then you do those differences, you get a bunch of zeros. All right? I'm going to write the sum down for you. I'm going to erase all my talk over here. We're done with this talk. I'm going to write the formula down. It's a formula derived in the text. Let me erase this. I want to point out we know the answer. We just did that, 165. And let's write this formula down. All right? So I'm going to be doing this formula. And someone says, what formula are you talking about? And we'll tell you what it is. It's this thing over here. I think you remember me doing that, right? Let's write this down. Sn. Give me 1 second. A1 times n plus n minus 1 over 2, right? I'm sorry, I forgot to put something down. I wanted to go forward, but that's crazy. D1 plus n minus 1, n minus 2, over 3 factorial, which is 6, D2. I'm not going to put down a D3, right? And why is that? Everything that follows after that will be a 0. All right? Now, someone's going to say, if you did this thing, what's the n going to be? Well, I got to think about that, right? And let's think. Again, we already went through the problem. And thinking about this, what am I going to do over here? Well, I know the A1. That's 1. Again, you might be struggling with the n. What's the D1 is 2. What's the D2 is 1. Yeah, we're struggling with that n, right? Oh, I didn't mean to put a line there. Sorry about that. All right, let's think about it. And what do you got? Well, if you think about it, right, we're starting with a pile, right? 9 shots in the bottom. So you have 9, 8, 7, 6, 9. Let's put that down. And this would be 9 times 8 over 2. This would be 9 times 8 times 7 over 6. I got some arithmetic to do here, right? 9. Oh, boy, it's going to be a tough one, right? 2 goes into 8 4 times, 36. Times 2. Oh, I forgot to put a plus sign over here. Sorry about that. This is going to be tough. So 3 goes into 6 2 times. Goes into 9 3 times. 2 goes into 2 once. Goes into 8 4 times. And let's see what you get there. You get 12 times 7. Let's write this down. This is 9 plus 36 times 2 is 72. And 12 times 70, I'm sorry, 12 times 7 is 70 plus 14, 84. I got to do some addition. 9 and 71, 81. 81 and 84 is 165. That's what we're getting. All right, let's take a look at the problem set. I want to point out the problem set. What are you doing? You're given a sequence. You're going to use a differential method to find out. All right? Now, of course, this one over here, it says the first term in terms of a sixth order difference. But when they say that, they're telling you got to go out to the six. I point out what I mean by that. 1, 2, 3, 4, 5, 6. And we did that. All right? So I put the work down there. I put the D1. By the way, maybe I didn't write the A1 down for you. I'll write that down for you. A1 is equal to 3. And we're going to find the first term of the sixth order difference of the series. Let me see. Find the first term of the sixth order of the difference of the series. Oh, they just want me. I'm sorry. They just want me to do this table over here. They're not asking much else than that. All right. So that's not so bad. All right. Yeah, I did that. All right. So it's over here. Okay. This one I find the 15th term of the sum, the first 15 terms of the series. Again, differential method. Turns out to be pretty nice. Let me write the A1 down for you. The A1 is 1. It peters out pretty quickly, and this is good news. I put the formulas down for you, and I go through the work. All right? So I tell you what A15 is, and I tell you what the sum of the first 15 terms is. All right? Now, again, if you think there's an error, well, I'm not saying there's not an error. I'm just saying I don't think there's an error. I think I've done a pretty good job in this over here. I'm using the differential method to answer this question. By the way, the A1 is 5 here. It peters out pretty quickly. You get a 0 by the third difference. Over here, I put the formulas down for you. I tell you what S15 is. And I tell you what A14 is. Yeah, I think I did okay on that one. So let's do the next one over here. Is that what they asked for, though? A14, S15. I'm sorry. This is the reason I looked at it. So 14 and then said 15. I think there's a mistake here. All right, I have to look at it. But I don't think they asked for, I think they asked for S14. Let me see if that's true, by the way, because I have to correct it. Yeah, I made a mistake here. This will be correct. I need to correct this. You're not going to see this when you look at the notes, by the way. I'll correct the notes. All right, if I remember to correct. This one over here, find the sum of the first n multiples of 3. Well, I'd write that down. All right, I did write that down, and I want to find the sum of it. I wrote it down over here. I'm going to say it looks like an easy question to me. I'm not saying it's a difficult question, and I put my work over here. I also did it by the differential method, which you may want to go through. All right? 5, same type problem, right? 6, the shot problem, right? Shot pile shape of a pyramid with, square base. What square base mean? It would be 25 shots by 25 shots. But it goes up like a pyramid, which means the top of the pyramid would have one guy in it. All right, one guy in it. So you'd really have the base would be 25 squared. The next up from it would be, 24 squared. And then you go all the way up to 1 squared. And I got to be honest with you, summing this together is really simple if you know sum formulas. For example, the sum of the squares is right over here. And I don't mind you doing that. Like, I think the differential method in this one, it's overkill. But you could do the differential method too. You get the same answers. So this would be the sum. And you might go through differential methods. You get the same sum. All right? Again, another differential method problem. This is a differential method where the sum of the first 10 terms. You can do that using differential method. We write down the term, A10, and we write down the sum, A10. Again, if there's an error, you bring it to my attention. All right? The sum of the squares are the first n multiples of 2. I write it down, by the way. And then I go through the differential method to do it. All right? I know it's tough, but you go through it. All right? And again, these are more abstract because it's AN, right? That's pretty simple to do that. SN, also not too bad to do. This one over here, differential method, and this one here. Pile of shots. Hard to understand sometimes, though. Find the number of shots in a pile of 9 courses with a rectangular base if the number of shots in the longest side of the base are 24. You might have to think about that one, all right? That requires some thinking. And I'll be honest, when I'm doing the problems, I got to think about them too. I have to think about what they said. And that's an important thing, thinking about it. Same thing for number 12, on the shot problem. This is a truncated shot problem. What does that mean? Someone's taken from the top. All right? It happens. Not bad. Reasonable looking question. Again, you might find the work hard, but it's reasonable. Reasonable. There's a lot of questions, though, aren't there? And someone says, did you really work through those problems? I worked through every single problem, by the way. And not only working through them on a piece of paper, typing them up. Right? It's a lot of work. Right? If I can do it, you can do it. All right, what do we get to? We eventually get to Sage. All right? Sage is a computer algebra system, or a CAS. It's free, open source. I would recommend looking through some of the code, but my goal over here is to get you guys to look at the work. What work we're talking about, the exercises. If you see any issues with the exercises, though, and you're saying, oh, you made a mistake, I'll be more than happy to correct it and give you credit for it. So please look at my work. If you have any comments on the work, though, please reach out to me and let me know that you believe there's problems with my work, all right? And this for people who have access to the PDF. If you don't have access to the PDF, me scrolling through these things is probably not much help to you. But if you have the work, you can look at the work and, get through it. And that's an important thing. The videos are not a way to work on problems, by the way. The way you want to do this is, have the PDF, all right? Have the published document. And again, only now only the Prison Mathematics Project participants have it. But in the future, I'll be publishing it, all right? And you can have access to it if you want. Just reach out to me and I'll let you know where to get it, all right? So again, if you have questions on this, tell me what section you're in, like 110.3. Tell me you have problems with number 1. You say it's wrong. You tell me why it's wrong. And I'll certainly take a closer look at it. Thank you for paying attention.